Hi, a very good day to all. Now we are going to discuss briefly about classification in this session. To introduce classification, it is nothing but a simple data mining function. It is going to classify a collection of data items under several categories of classes as required. The accuracy of the classification process rely on how accurately it is going to predict the target class for a new set of data automatically. For example, now we have digits 1 to 9 in our collection. We have two classes, odd and even. The numbers 1, 3, 5, 7 and 9 are in odd class, or we can say that the numbers 1, 3, 5, 7 and 9 are labeled as odd, and the numbers 2, 4, 6 and 8 are in even class. Again we can say these numbers are labeled as even class. Now if we introduce a new element 10 into our collection, the classification algorithm has to decide automatically to which class the new element has to fall under. Now coming to the process of learning, it can be categorized as two types. One is supervised learning, the another one is unsupervised learning. Coming to the supervised learning, it requires a labeled set of data for training. With this training data, it learns how to label a new data. Thus, supervised learning means it will have a set of training data. The training set must be labeled one. Next, coming to the unsupervised learning, it does not involve any training data. The labels of the classes are also not predefined. Whereas in supervised learning, the labels of those classes are predefined. The unsupervised learning tries to examine the relation or similarity between the collection of items and group them in required numbers. They does not involve any training data, or they don't have any predefined labels. This is the major difference between supervised and unsupervised learning. Classification comes under supervised learning since it involves a training set of data. Here is an example for learning. The first column, three pictures, represent how an arch should be. The second column, three pictures, represent how an arch should not be. With these examples, we construct a state diagram from which we can classify a new picture whether it is an arch or not. Next, coming to the process of supervised classification, we have a step-by-step instruction for supervised classification here. The input to the process is the training set with multiple features, where each record is tagged with a class label. Analyzing the features of the given input, the classification algorithm tries to develop a model for each class. The developed model is called the predictor. The predictor further helps in classifying the new set of data, also called as test data. Here is an example to define the model construction process. Here, the training data has three features: name, rank, and years. With these features, the records are labeled as tenured or not. The classification algorithm develops a classifier model as if a person is a professor, or if he or she have more than 6 years of experience, then they can be labeled as tenured, else labeled as not tenured. This is what the classification algorithm learns, and this is our predictor model now. Now, with the developed classifier model or a predictor model, we try to label a new set of data, also called as test data. Now let us pass an unseen data to our classifier. A person named Jeff with the rank of professor and 4 years of experience is now Now our input to the classifier model. Our classifier model is clearly trained that when a person is a professor, then he must be definitely labeled as tenure. Thus, the output is tenured. This record is labeled with tenured S. Now, here is another example. Clearly observe the given set of data. With these given data, now you are going to predict the category for the new input. Can you guess the category? Yes, it is negative. Now coming to the applications, the major applications of the classifications are email routing, where our emails are categorized as primary mails, promotion mails, social mails, etc. in our mailbox. The next is spam filtering to classify the incoming mails as spams or not. Next is the news article category determination. We can see in newspapers and e-magazines that the newses are classified under several topics such as politics, sports, entertainments, etc. The last one is the personalized newspaper. There are different supervised learning methods available. A few are listed here, such as nearest neighbor method, logic methods, probabilistic methods, and weighted scoring methods. Let us briefly discuss about the first two methods. Coming to the nearest neighbor method, when a new data is introduced, it tries to identify k similar items to the new data. Among the k items, the most frequently occurred label is considered as the label for the new items. Next method is the decision rules method. It comes under the logic method. The rules are framed with the features and their possible values. For example, here we have temperature, headache, weakness, nausea as attributes. From the given data, the following decision rules can be framed. If the headache holds yes, then the flu is definitely yes. Similarly, we can form the below three rules. The performance of the classification algorithm can be evaluated by F measure. F measure is calculated by the precision and recall values. Precision is nothing but the number of correct positive predictions out of the total number of positive predictions, where the recall is given by the number of correct positive predictions out of the total number of positive class documents. With the precision recall, we can define the F measure by 2 whole divided by the inverse of the precision plus the inverse of the recall. This is the overview of what is classification and how it is done, where it is used, and how it is evaluated. Thank you.